All right, so let's go ahead and graph one of these functions. It's a quadratic function, and it's in standard form. I can see the quadratic term. There is a linear term there, and there is a constant, and that's where we're starting off with. So again, as a reminder, let's start off with that easy money here. We know for a fact that if something's in standard form, let me go ahead and plot it right away. Our C value is 9, our constant is 9, our y-intercept is 9. Might as well just get on the graph right away and get yourself moving in the right direction. Now from there, this is the most math work we have to do in this unit in terms of calculating a specific thing in the axis of symmetry. And we know that formula is negative b divided by 2a. So in this scenario, what is the b? What is the a? Let's go ahead and plug it in. So we start off with negative b divided by 2a. Let me set up a skeleton here so I can plug some things in. So in this situation, my b value ends up being negative 8. And of course, as you can probably see, if somebody's going to mess up something here, they're going to not have that negative symbol hanging out there in the front of the b value, which happens to be negative 8. A value here is 2, so I can now go ahead and do a little bit of math work on that and clean some things up. Negative 8 is actually positive 8. 2 times 2 is 4, and we're saying here that my axis of symmetry would be 8 divided by 4, which is 2, which is fantastic. And I'm going to take a moment to kind of sort of just highlight my mirror there. And I'm going to calculate the vertex, but before I calculate the y value for the vertex, I might as well just mirror the point that I already know would be there. So I know I have the y-intercept is 0, 9. That's 2 spots away from the mirror, from the axis of symmetry. On the other side, there should be a mirrored point, which in this case is going to be at 4, 9. Now let's go ahead and I'm going to take that axis of symmetry, I'm going to plug it into the function. So I had 2x squared minus 8x plus 9. I'm now going to take the axis of symmetry and plug it in, and like we started this unit, my hope is that you can just go ahead and type this into a calculator when you get done with it. I'll real quickly say the math work involved, but we have 2 squared is 4, 4 times 2 is 8. We have 8 minus 2, which is negative 16, and then I have a plus 9. 8 minus 16 plus 9 ends up giving me 1. So on that axis of symmetry, I do have a point at 2, 1. That does end up being my vertex. From that location, I can do the step pattern. If I know that I'm at 2, 1, and I want to finish this up with the step pattern. Remember that step pattern? We're always starting off with 1, 3, 5. But in this case, what's my a value? My a value is 2, which means now plus 2, plus 6, and plus 10, although I don't think we're going to quite get there. Alrighty, so that means that if I go up to the right one, I would be right there, and it has a mirrored point. And hey, look at that. If I go up 6, I'm at the orange point. So I'm happy with that, with what we have on the graph. I'll go ahead and take a moment, connect those dots as best as I can on this tablet. And there is my quadratic. So that's how we graph that function. Get the easy point on there first. If I can get a y-intercept on the graph, go ahead and for it. I got to calculate axis of symmetry. Be careful with the formula. Be careful with that negative b. Draw a skeleton first. I think that's helpful. Once I get the axis of symmetry, plug it into the function. and get your y value, get that k value for your vertex, and then of course use the step pattern to get the rest of the points.